In our previous video, we discussed the conditional and biconditional operators and their truth tables. And in this video, we're going to go over logical operator precedence, types of propositions, and some rules for writing truth tables. So, the logical operator precedence for the operators that we've discussed so far is as follows. The first to be considered is our negation operator. After that, the and or the conjunction and disjunction are considered. Conjunction first, and then conditional and biconditional. Now, we're going to discuss this a bit more later and actually apply it, but for now, it's useful to know this. Moving on to types of propositions. Now, you notice we have 4 here. So, tautological propositions and contradictory propositions are quite important to understand. A tautological proposition is always true regardless of the values of the propositional variables. Now, an example of this would be P or not P. That will always be true. And the reason for this is that, we can solve this in a truth table quite easily, right? But just think about it intuitively. For an or operator to be true, one must be true. And if P is true, not P is false. And if P is false, not P is true, and vice versa. So that must always evaluate to true. A contradiction is a proposition that is always false regardless of the values of the propositional variables. An example of this would be P and not P, which has to be false, because there is no instance where P is true and not P is also true. Now, we'll discuss some other variations on this later, but for now it's just important to know that if a proposition is logically equivalent to true or logically equivalent to false, that would make it a tautology or a contradiction. Moving on, a contingency is every other type of proposition. So this is a compound proposition that can be true or false. And what is a compound proposition? It's any kind of conjunction, disjunction, etc. So P and not P, or P and Q, or P or Q, or P implies Q, and so on and so forth. Now, the final part of this video is rules for writing truth tables. Now, the main thing, and this is just a brief introduction to writing truth tables, but the main thing is you need to cover all variables. So, on all eventualities. So if I have 2 variables, I have to include all possibilities. I have to have a true-true, I have to have a true-false, I have to have a false-true, and I have to have a false-false. That's your rule 1. If you don't do this, your truth table isn't giving you all of the truth. The next thing is that if you're given something like P and not Q, don't skip columns. Before you get to P and not Q, do not Q. You have to do every column. Otherwise, your truth table is not going to be considered complete. In our next video, we're going to discuss De Morgan's laws and some of the other equivalency laws. And after that, we'll move on to some of our final propositional logic problems, and trying to understand how to actually work problems that you're given, and we'll look at some classic logical problems. All right.